Hello everyone, my name is AhmadNandaYumaRafi and my friend is OktavianNikky. Here we are trying to describe about adversarial search and game playing. For the first, adversarial search is a search where we examine the problem which arises when we try to plan ahead of the world and other agents are planning against us. And the first is the tic-tac-toe. The tic-tac-toe is a game in which two players alternately put X's and O's in compartments of figure formed by two vertical lines crossing two horizontal lines, and each tries to get a row of three X's or three O's before the opponent does. So I think all of us know about this rule of this game from tic-tac-toe game. So for the first player will choose O or X, and then the next player will choose against the first player O or X, and then it will create a new algorithm for this. This is the example. Before the game begins, there is no O or X, but after the first player move, there is one or first move, and then the second move, third move, and so on. And since there are nine possible first move, eight for the second move, and etc., this does not take into account games which finish in less than nine moves. And then, if we calculate all of the move that can appear in this game, there are 255,168 possible games. So many possibility in this game. So it calls the tic-tac-toe algorithm, which choose the turn after the player. And then this is the MinMax algorithm. This is how to say it, algorithm which implement in the multiplayer game. The first player is, it can be max or it can be min. And this algorithm used when a game is playing by two players which take turn playing, like I said before. And the MinMax algorithm is a recursive or backtracking algorithm which is used in decision making and game theory, and in, it provides an optimal move for the player, assuming that opponent is also playing optimally. As you can see over here, the first turn is for min. It chooses the lowest value from this all of the value. It will choose this, and the min algorithm will choose 3 because 3 is the lowest value. And then in the next turn, the max will choose 12 as a highest value in this line. So the key point of MinMax algorithm is, the first MinMax algorithm use recursion to search through the game tree, and the MinMax algorithm is mostly used for game playing in AI, such as chess, checkers, tic-tac-toe, Go, and Forest-toe players game. And this algorithm computes the MinMax decision for the current state. In this algorithm, two players play the game. One is called max and other is called min. And then both the players fight it as the opponent players gets the minimum benefit while they get the maximum benefit. Both players of the game are opponent of each other, where max will select the maximized value and min will select the minimized value. As their name, max will select the maximize and min will select the minimize value. And the minimax algorithm performs a depth first search algorithm for the exploration of the complete game tree. And the last is the minimax algorithm proceeds all the way down to the terminal node of the tree, then backtrack the tree as the recursion. Like this. This is the example of the minimax algorithm. The value is like this. In this tree, the X has probability to win. In this tree, the probability to win is draw. And in this tree, O has probability to win. But if we create a tree, we know more possibility in this game, like this. And the basic idea is just move with highest minimax value is equal to best achievable payoff against best play, and performs a complete depth first exploration of the game tree. It will explore of all of the tree and choose what is the best move that uh, AI or human can play. And for the next algorithm, my friend will explain it.
Thank you, Rafi, for the explanation before. And from here, I will take the turn to explain about alpha beta pruning algorithm. As we have seen in the MinMax search algorithm, that the number of game stats it has to examine are exponential in depth of the tree. Since we cannot eliminate the exponent, but we can cut it to half. Hence, there is a technique by which, without checking each node of the game tree, we can compute the correct minimax decision, and this technique is called pruning. This involves two threshold parameters, alpha and beta, for future expansion. So it is called alpha beta pruning. It is also called as alpha beta algorithm. Next, Ravi. So the key point of alpha beta pruning is each node has to keep track of its alpha and beta value. Alpha can be updated only when it's max turn, and similarly, beta can be updated only when it's min chance. Max will update only alpha value, and min player will update only beta value. The node value will be passed to upper nodes instead of value of alpha and beta during go into the first of three. Alpha and beta value only be passed to the child nodes. And alpha beta pruning is a modified version of the minimax algorithm. It is an optimization technique for the minimax algorithm. Alpha beta pruning can be applied at any depth of tree, and sometimes it not only prune the tree leaf but also entire subtree. Al- Alpha Alpha is the best choice or the highest value that we have found at any instance along the path of maximizer. The initial value for alpha is minus infinite, and beta is the best choice or the lowest value that we have found at instant along the path of minimizer. The initial value for beta is plus infinite. The condition for alpha beta pruning is that alpha is larger or equal beta. Next slide. And this is the example of the alpha beta pruning, which is the grayed out subtree don't need to be explored when moves are evaluated from left to right, since it is known that the group of subtree as a whole yield the value of an equivalent subtree or worse, and as such cannot influence the final result. The max and min level represent the turn of the player and the adversary, respectively. So, for Rafi, please close the presentation.
Okay, Nikki, thank you. My name is Rafi and my friend is Nikki. Thank you for watching our presentation and see you later.